Alright, let's continue on with part D. Here we go again to a small graph, and let's change this color up. So I'm going to do the same thing I did last time, especially right to the side. If they got the length specified and length diagonals, we'll stick with the same game plan. So A is going to be -3, 5, -3, -5. Let's put you down here. That's A. B is going to be at 5, 1. C is going to be at 2, 3. D's at -2, 0. Interesting shape. Connect them up. Definitely does not look like a parallelogram. Let's label this. So A is the first one. B's out here. C's up here. 2, 3, and then D's over here. Alright, let's do this. So let's change the color up. Get something a little brighter. Alright, AB. Let's do the big side down here. So AB, distance formula. Square root, so AB. So that means we're going to go 5 minus -3, double sign, no biggie. And then we're going to do 1 minus -5, squared. So double sign here, so that's a plus, so 5 plus 3 is going to be 8 squared. And we got 1 plus 5, which is going to be 6 squared. So that's going to be 8 times 8 is 64 plus 36, which I believe is going to be 100. If that's the case, that brings us all the way down to a nice, cool 10. So let's label that down here, 10. CD. So CD, we're going to do -2 minus 2 squared plus 0 minus 3 squared. And this is going to be -4 squared plus -3 squared. So that's going to take us up to 16 plus 9, which is going to give us a 25. So square 25 is a nice 5. So BC, we got that one out. So CD is going to be 5. So we're going to go ahead and label that 5. Let's change the colors up. Well, I guess we can stay the same. CD. -2 minus 2. Oh, wait. That's the wrong one. We'd be going BC here. Alright, BC. Right here. BC. So 2 minus 5. Plus 3 minus 1. Alright, so let's keep simplifying. 2 minus 5 is -3. 3 minus 1 is 2 squared. So this is going to be plus 4. It's going to be 13. Yikes, what's the square root of 13? Square root of 13 is going to be 3.6. BC is 3.6. Okay, so DA. DA. So I'm just going to go in that order. So A is the second point. So I'm going to start off with A. So -3 minus -2. Have fun with the double signs here. Plus -5 for that one minus 0. Alright, double signs, that's a plus. So we got -3 plus 2. So it's going to be the same thing as a -1 squared plus, and -5 minus 0 is -5. So you've got -1 times -1 is 1, plus -5 times -5 is positive 25. So now we're at the square root of 26, which is going to be just a little over 5. And that is 5.1. Okay, so we've got all 4 sides. Now, you can sort of tell right off the bat that it's not going to be isosceles. It definitely looks isosceles because these sides look parallel. We didn't really do the slopes though. They wanted to link the sides. But one thing to notice is that if it's going to be a isosceles trapezoid, that means you still have to have the 2 sides be the same length, which they definitely aren't. So you can go ahead and throw this off the list. It definitely should be a triangle, just a trapezoid, regular trapezoid. Now another check for the isosceles though is the diagonal should be the same. So let's go ahead and go through that one. I'll show you how I probably would have done it myself. AC. So we're going to go AC. We're going to go with this one right here. This diagonal. So using A and C. So A and C. All right, here we go. AC. So 2 minus a -3 squared plus 3 minus a -5. All right, so double sign. So that's 2 plus 3, which is going to be 5 squared plus, and that's a double sign, plus 3 plus 5 is 8. So we're going to get 25 plus 64, which is going to be 25 plus, was it 89? And let's take the square root. 9.4. Alright, and let's change the color up again. What color we're not going with? Let's go back crazy color. Alright, so here we go. Now we're going to do the BD diagonal, which is going from here to here. So we're going to use B and D. Okay, so BD. So -2 minus 5 squared plus 0 minus 1. Just make sure you're looking at the same or the right coordinates. So let's crunch this. So -2 minus 5. So -2 minus 5 more gives you -7. Plus 0 minus 1 is just -1. So -7 squared is going to be a positive 49. Plus -1 squared is just 1. So we're back up to square root of 50. Which, if I remember right, wasn't that like 7.1? It was. So, alright. So here you have it. Your diagonals are not congruent, which means it officially knocks out the isosceles. Not congruent. So that means you are just stuck with a trapezoid. But I kind of caution you on this one because a definition for a trapezoid, you really want to know you have one set of parallel sides. So here's something else that I would have done. Let me change this color one more time. All right. If you do the slope triangle, that means you're going to go up 1, 2, 3. And you're going to go over to the right 1, 2, 3, 4. That means the slope of this top side is, make sure you rise, which looks like 3, over the run, which looks like 4. So again, you go up 1, 2, 3, go to the right, 1, 2, 3, 4. So we got that slope. Let's do the bottom slope. I just want to make sure these are parallel. So slope triangle. Here we're going to go across 1, 2, 3, 4, 5, 6, 7, 8. And we're going to go up 1, 2, 3, 4, 5, 6. So the rise would be 6, the run would be 8, and that definitely will reduce to 3/4. So at least we have one set of parallel sides. And I'm just being thorough. Okay. I just want to make sure it's a trapezoid to begin with. All right, but that's it. So we have a trapezoid with one set of parallels. It is not an isosceles trapezoid because these two sides are not congruent, and the other way we prove that is because the diagonals are not congruent. A lot of work for one problem. All right, y'all. Hope this helps you.